Well, hello Internet. Today we have a new problem to solve. Given a sorted W linked list, how can we convert it into a binary search tree? For example, let's assume we have this W linked list with elements from 1 to 7. The output should be the binary search tree shown on the right side. Since it's a sorted W linked list, the middle element would represent the root node, and the elements on the right side of the middle element will be a part of the right subtree, and the element on the left side of the root element, which is 4, will be a part of the left subtree. And we can basically follow that pattern inside the left and right parts of the list and solving them as their own individual subproblems. So the basic approach that we're going to follow here is, since we don't have access to the middle element right away, what we're trying to do is we're trying to construct a left subtree first, and then we know which is the middle element and we assign that to a root node, and then we construct the right subtree. Let's see how the code will look like for this. We start with initializing a binary tree node class with a value and a left and a right children, and now we'll define a doubly linked list with a value and a previous and a next pointers. And now we'll resort to writing our utility method, which will take in the head of the list as an argument. And the first step is to find the total number of elements in the list, so we can find out where the middle element is, and then based on that we can architecture our algorithm. So for this, a simple way to find out the length is to loop over the list once and have a counter which increments till we encounter a null pointer. And now we can use this length element to pass into another utility method, which will take in our head along with two more variables. The first one will be the starting index, and the second one is the ending index. For example, we'll pass in 0 as the start index and length -1 as the ending index here. Let's write our utility method. Remember, we're going to call this method recursively, so we will need a terminal condition so we know where our recursive calls end. As we discussed earlier, since we can't really get an access to the middle element in a linked list directly, we'll first try to construct the left subtree by finding the middle index and then recursively calling the same utility method construct, passing in the start and end values as 0 and mid -1. After that, we assign the head value to the root node, and we assign the previously generated left value to the root's left pointer, and then we also increment the head pointer to be pointing to the next node, and the next of head to next of head. And once we have that increment, we find out the right node in a similar way as we found the left node by passing the middle +1 and the ending value. And once we have this, we assign this to the root's right element and we return root. So I've made some additions to the code. I've used some utility methods to see how our linked list and our tree looks, and I have initialized a doubly linked list to be able to test this use case. So let's try to execute this once. Here we go. So as you can see, we initialize the linked list with elements from 1 to 7, and the output is a tree with the 4 as the root element, and with children 2 and 6, and 2 further has its left and right child as 1 and 3, and 6 has 5 and 7 as its children. So that is all for today. For more such videos, please make sure you like, share and subscribe, and drop a comment if you want to see more such videos. Thank you for your time. Goodbye.